Hello everyone, I am Amy, the math tutor at WorkSmart Math. This short video will focus on an essential differentiation concept known as the chain rule. In comparison to the product and quotient rule, it is the most difficult for students to grasp. The trick is to understand how the formula works. The approach remains consistent regardless of how the questions are changed. Finally, we will apply our understanding by working together to solve a question. A good place to start is the fundamentals. Let's look at the notations, which serve as the foundation for differentiation formulas. We will take a look at the notations of functions and the notations of derivatives before looking at the formulas. In front of you, there are three different representations of functions. The first two are used interchangeably. The variable is normally x for y and is written inside of the brackets for function f. The difference between the third and the second notation here is the variable x is replaced by another function gx, where x is the variable. So we have a function f, which we refer to as the outer function, and gx as the inner function. A shorthand notation for this layered function is capital Fx. Now, let's have a look at the notations of derivatives. There are two different ways. One is to simply add a little dash on the top right corner like this. The other way is using dy over dx. D stands for differentiate, and the variable that we are differentiating with is in the denominator. This notation looks like a fraction and can be treated as a fraction. The first formula that I would like to talk about is this one. Depending on which curriculum you are using, the letter U can be replaced with anything else. So we have dy over dx equals dy over du times du over dx. If we are treating these notations as fractions, we can easily cancel du and du out. This leaves us dy over dx on the right-hand side, which is the same as the left-hand side of the equal sign. So this formula works. What this formula says is the derivative of y with respect to x equals the derivative of y with respect to u. Whatever u is, we don't know. And then we multiply that with the derivative of u with respect to x. So this tells us u is actually a function of x. So we can write this as u dash x using the other notation. And if you're more comfortable with this one, this can be written as this. Okay. Now, this is formula number one. The other formula, you may have seen it like this. I'm using the shorthand. So what this means is the derivative of this layered function with respect to the variable x equals the derivative of the outer function f with respect to gx, multiplying with the derivative of gx. Okay. When you compare these two formulas, if we use the dash notations, you'll see this u here is the same as gx. And this tells us ultimately these two formulas are the same. They just look different because they are written in different notations of differentiation, but they are the same. It's up to you which formula you like to use, but the method is we need to differentiate the outer function with respect to the inner function and then multiply that with the derivative of the inner function. Before we look at an example, I just want to point out that when we differentiate the outer function with respect to the inner function, we need to keep the inner function as it is. Try not to change anything about it. Keep it as it is. For example, when we differentiate, say, x to the power of 3, we get 3x squared. Did we do anything to x? No, we didn't. We only changed the power. We moved the power around and give it a new power. We didn't change anything to x. X is still x. Now, back to the formula. Gx could be an expression about x. It's very tempting to do something about it, but please don't when you try to figure out the derivative of this. You only differentiate gx in the second part of the formula. Okay, let's have a look at an example. Feel free to pause the video and give it a go. All right. Now, if this was a question like this, we know how to differentiate easily. However, it's not just x here. It's 1 take away 6x squared. So we have an inner function, and that makes something 2 power 4 the outer function. Chain rule comes to rescue. Let's differentiate the outer function with respect to the inner function. So we get 4 and keep the inner function as it is. Okay, and then multiply that with the derivative of the inner function, which give us negative 12x. Remember to use the brackets for negative expressions. Okay, let's simplify this. And that is the final answer. A lot of students struggle with the chain rule simply because they do not understand the notations in the formula. Remember, the method will always be the same no matter how they change the question. All you need to do now is to go and practice different types of chain rule questions with this method and have fun. If you find this video helpful, please give me a thumb up and subscribe to my channel for more. I also offer online tutoring lessons that can be easily booked at www.worksmartmath.com. Why work harder when you can work smarter? See you next time.